So today we are going to discuss how to find the eigenvalues and eigenvectors for the 3 cross 3 matrix. Already in the previous lecture we have discussed evaluating eigenvalues and eigenvector for a 2 cross 2 matrix. So now I am going to evaluate the eigenvalues and eigenvector for this matrix E. Okay. So general characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Here s1 is equal to trace of A. Trace is nothing but sum of the diagonal elements. So 3 plus 5 plus 3, which is equal to 11. Then s2 is equal to sum of the minus of determinant of diagonal element. Okay, so here the first diagonal element is main diagonal element is 3. Corresponding minor matrix is 5 minus 1 5 minus 1 minus 1 3 plus second diagonal element is 5. Corresponding minor matrix is 3 1 1 3 plus third diagonal element is this 3. Corresponding minor matrix is 3 minus 1 minus 1 5. So now find the determinant. 15 minus 1 plus 9 minus 1 plus 15 minus 1. So which is 14 plus 8, 22 plus 14 is equal to 36. So S3 is equal to determinant of A. So which is equal to 3 into 15 minus 1 minus of minus 1 plus 1 into minus 3 minus of plus 1. Okay. Then plus 1 into 1 minus 5. So which is equal to 3 into 14 plus 1 into minus 2 minus 4. So 3 14 is 42. 42 minus 6 is equal to 36. So the corresponding characteristic equation is lambda cube minus 11 lambda square plus 36 lambda minus 36 is equal to 0. So this is from here, right? So 1 implies you will get the characteristic equation. Next, find the roots of this equation as the eigenvalues. Okay. So we have the characteristic equation lambda cube minus 11 lambda square plus 36 lambda minus 36 is equal to 0. By synthetic division you should find the at least one value, or you can use the scientific calculator. You can find the eigenvalues of a matrix. So 1 minus 11 36 minus 36. So here sum of the coefficients is not 0. 1 is not a root. So minus 1 also cannot be root, because sum of odd powers equal to sum of even powers, then only minus 1 is a root. So here 1 and minus 1 are not the roots. Then we can go for 2. So 2, 1 plus 0 is 2. Sorry, 1 plus 0 is 1. 1 into 2, 2 minus 9. Minus 9 into 2 is minus 18. So here is 18. 18 into 2 is 36. So it is 0. So lambda minus 2 into lambda square minus 9 lambda plus 18 is equal to 0 by synthetic division. So lambda equal to 2 is one of the root from here. So if you multiply you should get 18, and if you add you will get 9. So minus 6 minus 3 are the possibilities, right? So lambda minus 6 lambda minus 3 equal to 0. So lambda equal to 6 comma 3. So lambda equal to 2 3 comma 6 are the eigenvalues of matrix. So now next step we should find the eigenvector. So for the finding eigenvectors we need the matrix A minus lambda I, which is equal to given matrix is 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. So from the diagonal you should subtract lambda. So that is A minus lambda I matrix. So we have to evaluate the eigenvectors one by one for each and every eigenvalue. When lambda equal to 2, a minus lambda I into x is equal to 0. A minus lambda is 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1. So 1 minus 1 3 minus lambda into x is some arbitrary vector x1 x2 x3 is equal to 0 0 0. So 3 minus 2 is 1. If you put lambda equal to 2, 1 minus 1 1 minus 1 3 minus 1 1 minus 1 1. So x1 x2 x3 is equal to 0 0 0. So here first and third row are same, right? First and third row are same, so we cannot use for finding the eigenvector. So from the first two, so now multiply, you will get the equations x1 minus x2 plus x3 equal to 0, and the second row will become minus x1 plus 3x2 minus x3 is equal to 0. Third equation and first equations are same, so you can leave that, right? So from here you should find the solution of system of equation. So for that I am using cross ratio method. For cross ratio method, just take x1 x2 x3. So right, when you are finding for x1, when you are finding the solution for x1, you should apply the coefficients of x2 and x3. So therefore x2 coefficient is minus 1 3, x3 coefficient is 1 minus 1. When you are finding x2, you should use the coefficients of x1 and x3. Therefore already we have x3 coefficient. So now x1 coefficient is 1 minus 1, and for finding x3 we should use x1 and x2 coefficient. So already we have 1 minus 1, so x2 coefficient is minus 1 3. Now take the determinant of this one for x1. What is the determinant value? 1 minus 3, that is minus 2. Okay. Next, for x2, wait 1 second. Take the determinant of this one. So this will be minus 1 plus 1, which is equal to 0. And when you are finding x3, take the determinant of 1 second. So this value, right? So which is equal to 3 minus 1, which is equal to 2. So the eigenvector is x1, x2, x3 is equal to x1 value is minus 2, x2 value is 0, x3 value is 2. So if you simplify this vector minus 1 0 1, this is also a eigenvector. So because it is a solution, so eigenvector is never 0, therefore you should take a non-zero solution always, because here in this set of equations we have always 0 is a solution, but we should not take the 0 solution, we always need a non-zero solution. So you should find at least one solution which is non-zero, and we know that the system has two equations with the three unknowns, so it has infinite number of solutions. Among them we should need at least one solution which is non-zero. So this is a base vector actually. This minus 1 0 1 is a base vector. So minus 2 0 2 is also a solution, minus 3 0 3 also a solution, minus 4 0 4 is also a solution. Multiple of this vector, any multiple of this minus 1 0 1 is the eigenvector corresponding to lambda equal to 2. So next, when lambda equal to 3, when lambda equal to 3, A minus lambda matrix is 3 minus lambda minus 1 1 minus 1 5 minus 1 1 minus 1 3. 3 minus lambda, here it is 5 minus lambda. So when lambda equal to 3, this will become 0 minus 1 1 minus 1 2 minus 1 1 minus 1 0 into x1 x2 x3 is equal to 0 0 0. So here all the three rows are different, so you can take any two rows. Instead of evaluating this equations, you can directly from the rows itself you can apply cross ratio technique. So x1, when you are finding x1 x2 x3, you have to take the coefficients of x2 and x3 when you are finding x1. So 2 minus 1 minus 1 0 and then minus 1 1 2 minus 2 1 2 1. Okay, so here we should start from here, and then you have to take this vector, and then you have to take this vector and complete with this vector. It is like a rotation. So x1 is equal to, now determinant of these two is 0 minus 1, which is minus 1. x2 is equal to determinant of these two, so you will get minus 1 minus 1 minus 0, so minus 1. For x3, so you should take the determinant of these two, so minus 1 and then minus 2, so it is minus 3. So x1 minus 1, x2 x3 is equal to so here we have minus 1 0 minus 1 1. So there is some mistake, actually here it is minus 1, so it will be minus 1 plus 2, so this will be plus 1, right? Plus 1 and then it is minus 2, so totally it is, actually this will be plus 1 minus 2, so minus 1. So the vector is minus 1 minus 1 minus 1, which is equal to simplified form as 1 1 1. So this is a eigenvector. Multiple of any this vector is again a solution of the system of equation. Therefore 2 2 2 3 3 3, those are all the solutions. So among them we need only one solution. So you can assume 1 1 1 is a base vector. Okay, next we should evaluate for lambda equal to 6. So the matrix is 3 minus lambda minus 1 1 1 minus 1 5 minus lambda minus 1 1 minus 1 3 minus lambda. So when lambda equal to 6, this will become minus 3 minus 1 1 minus 1 5 minus 6 is minus 1 minus 1 and then 1 minus 1 minus 3 into x1 x2 x3 equal to 0 0 0. So now we can assume any two rows. So if I take these two rows x1 x2 x3 by cross ratio method, minus 1 minus 1 minus 1 minus 3 minus 1 1 minus 1 minus 1. So here we can also assume the first two rows, or you can assume the first and the third row. That is also possible. You will get the same answer, or you will get the multiple of this vector, some other vector. Okay. So x1 is equal to 3 minus 1, that is 2. x2 is equal to minus 1 minus 3, that is minus 4. x3 is equal to 1 plus 1 equal to 2. So x1 x2 x3 is equal to 2 minus 4 2, which is equal to 1 minus 2 1. Okay, so if you choose first two rows, you will get some other vector, but it is a multiple of this vector. Okay, so maybe it may be you will get 3 minus 6 3, or some other multiple of this vector, or 2 minus 4 2, that is also possible, and 4 minus 8 4, that is also possible, or 1 by 2 minus 1 1 by 2, that is also possible. So the multiple of any vector will be eigenvector. So you will get any multiple of this vector, you won't get different vector. It cannot be not a multiple of this 1 minus 2 minus 1. That is you have to keep it in mind, right? That's it. So now we have the conclusion. We have the three eigenvalues: lambda equal to 2, lambda equal to 3, lambda equal to 6. For lambda equal to 2, we get the eigenvector minus 1 0 1 or 1 0 minus 1. Lambda equal to 3, it is 1 1 1. For lambda equal to 6, 1 minus 2 1. That's it. So this is the way you should find the eigenvectors. So here we have the different eigenvalues, so we are getting different eigenvectors. But if you have repeated eigenvalues, that means if the eigenvalues are repeated 2 comma 2 comma 6, or suppose 1 1 1, so in those cases we need to handle the problem in different way. So we will discuss in the those problems in the next lecture. Thank you for watching.